3 anti-laws of indices, part 1. Under index notation, now consider the following. 5 times 5 times 5 times 5 can be written as 5 to the power of 4, where 5 is the base and 4 is the power or index. Therefore, a times a times a, n number of times, will be written as a to the power of m, where a is the base and m is the power or index. Multiplication of indices. Consider the following. We have a times a times a times b times b. Now this can be written as a different base with different index because only those with the same base can be grouped together. That means for our first base we have the letter a. This will be a to the power of 3. Okay, and the other one, letter b, this is of a different base. We cannot add the power together with a, so they'll be on its own. So this will be b to the power of 2. Now consider the following. If I have a to the power 3 times a squared times b squared, what will this be? This is actually a times a times a 3 times. So this is power 3 times. Okay, and if I were to multiply another a squared, which is a times a, there will be another 2 times. Okay, how many times will there be in total? There will be a total of 5 times. Only those that are of the same base can be grouped together. Therefore, a cubed and a to the power 2 have the same base. We will group these together as a to the power of 3 times plus another 2 times. It will be a total of 5 times. And then b squared is a different base on its own, so we cannot add the power for b squared together with a, so it will be b squared. Therefore, indices rule number 1 tells us that if I have a to the power m times a to the power n, where both of them are the same base, what we can do is we just need to add up the power, where this over here has n number of times, this one over here has n number of times, so we total, add them up together, m plus n. Division of indices. Consider the following. A to the power 5 divided by a squared. What exactly is this? This is actually a to the power 5. We can write division as fraction over a squared, which means a to the power 5 will means a times a times a. How many times? 5 times. Okay, there will be 1, 2, 3, 4, 5 of them in the numerator. And a squared will means a times a, which is 2 times. Now when we have fraction, we need to simplify it by cancelling out the common factors. So I cancel out the first pair. Now the moment I divide by letter a is not 0, I'll get 1. Now I cancel out the second pair, get 1 as well. What am I left with? I'm left with a to the power of 3 in the numerator. So in this case, I will write the final answer as a to the power of 3. Now let us take a closer look at the different powers. This is a to the power 5. This is a to the power 2. What did we do? We cancel out 2 pairs from 5. So that's why we have a to the power of 3. So this is actually a to the power of 5 minus 2. So in general, when we have division for indices, a to the power of m divided by a to the power of n, I will do a subtraction. A to the power of m minus n. For example, if I have a to the power of 100 divided by a to the power of 90, what will be the answer? The answer will be a to the power of 100 minus 90. That gives us a to the power of 10. Next, power involving indices. Consider the following. If, let's say, I have something over here, the whole thing square, what does that actually mean? Something square actually means I take whatever that's inside my bracket, multiply by the same thing itself 2 times. Now let's take a look at what is inside our brackets. We have a, b cubed, c to the power of 5. That means I will multiply itself a, b cubed, c to the power of 5. Now taking a look at the individual letters, alphabet. So firstly, I will have a times a. There are 2 groups of a, so this will be a to the power of 2. Then next one, let's take a look at b. I will have b cubed times b cubed. What is b cubed times b cubed? Now using indices root number 3, b cubed times b cubed means b to the power of 3 plus 3. I will have b to the power of 6. But this is actually, I have 2 groups of 3. So I'm taking 2 times 3 to give me 6. Next one, I will have c. This is c to the power of 5, c to the power of 5. What will this be? I have 2 sets of power 5. That means I will get c to the power of 5 times c to the power of 5, which is actually c to the power of 5 plus 5. That gives me c to the power of 10, which is actually I have 2 groups of 5. That gives me 2 times 5, 10. So what is the effect of the power? So when I have a, b cubed, c to the power of 5, whole thing square, it means I'll need to square the individual term. So I'll have a to the power of, originally this is 1. It will become a square. How did I get a square? I take a to the power of 1 times 2. And I need to look at my second letter, b to the power of 3. So now this will become b to the power of 3 times 2, b to the power of 6. And I also need to apply last one, the square, to power c. For the c, this will become c to the power of 5 times 2. Therefore, I will have a to the power of 2, b to the power of 6, c to the power of 10. So doing the question by both the method over here and using the power rule, we can get the same answer. So technically speaking, what is a to the power of m bracket n? This means a times m will be a times m n hence we will have n groups of the power n, which gives us a to the power of n times n. Now this rule is for your extra knowledge. If you do not know how to apply this rule, we can still do it by the method over here. Okay, where we can write them repeatedly a number of times to find out the individual power. Now, what happens if we have a fraction? For example, 3a squared over b to the power of 3. What does this mean? This means that every term inside my bracket will need to have the power 3. So, applying power 3 for every one of them. This is 3 to the power of 1. Okay, what will I get? I will get 3 to the power of 1 times 3, a to the power of 2 times 3, and b to the power of 1 times 3. That gives me 3 cubed, a to the power of 6, b to the power of 3. But this is not the simplest form. We need to work out the value for b is 3 to the power of 3. Now take note, 3 to the power of 3 is actually 3 times 3 times 3 is not 3 times 3. So 3 times 3 times 3 is actually 27. So writing this value in the simplest form, you'll get 27 a to the power of 6 over b cubed. What does this mean? This means if I have a fraction and to the power of n, every term inside the fraction will need to have the power m. It will be a to the power of m over b to the power of